Hello friends, today our topic is the HCF of algebraic expressions. So HCF, we should understand that these are the common factors. Okay, so common factors is the HCF, and generally while we are finding the HCF or LCM of algebraic expressions, we try solving these expressions with the help of algebraic identities and here we use the square cube. These two identities we generally try with the square and the cube identities. Then the second is factorization. Okay, factorizing we use these two techniques generally to solve the HCF and LCM of algebraic expressions. So here our first expression is a cube minus b cube. So I'm writing here first expression, that is a cube minus b cube, which is written as a minus b. The identity there is the algebraic identity a minus b and a square plus ab plus b square. This is the first. Okay, so the next, what is our second expression? Let's check the second expression. The second expression is 3a square plus 2ab minus 5b square. And now we can factorize this. 3 times 5 is 15, and let's try to find the factor of 15. So the prime factor of 15 is 5 and 3. 5, 3 is 15. So here we can see it is negative. So that means we have to subtract these factors and get 2. So 5 minus 3, we get 2. Here I am writing for 3a square plus 5 minus 3ab minus 5b square equal to 3a square plus 5ab minus 3ab minus 5b square. And if I take a common from here, then I get 3a plus 5b minus, if I take b common, then I get 3a minus minus plus 5b. So here we can see that 3a plus 5b and 3a plus 5b in both the bracket. So take one of the two, 3a plus 5b, and in the bracket the leftover is a, and here is minus b. So this is our second expression. And the third expression is a power 4 minus b power 4. And this one we can write as a square minus b square. So it's written in the format a square minus b square. This whole thing is a square, and this is b square. A square minus b square, which is equal to a plus b, a minus b. Again we can see that here is a square minus b square. It can be further factorized, so it will be a square plus b square, and this one is a plus b, a minus b. Dear friends, from all these three expressions we see that a minus b and a minus b is common. So I already told you in the very beginning that HCF is the common factor. So the common factor is a minus b, which is our answer. Now let's check the second question. Our second question is to find the HCF but using the Venn diagram. Okay, so let's see how we can do that. Our first expression is a square minus b square minus 2bc minus c square. So if you get this kind of expressions, check which variables are with the number 2. So see, with the number 2 we have b and c. That means we can combine the variables b and c together. So let's see, a square minus, now going to write this b and c variables together, b square minus minus plus 2bc minus minus plus c square. And from here a square minus this whole thing, now we can, if you see, then you get that it is the square identity a plus b whole square, where a is b and b is c. So I write b plus c whole square. And now I can compare this identity with the a square minus b square, where I get a plus b and a minus b. If I write minus b, that means here I get b minus c. And my second expression is b square minus c square minus 2ca minus a square. Here also I can see that the c and a is with 2, so I'm going to group c, the variables c and a, minus c square plus 2ca plus a square. From here I get this also a square identity, which is c plus a whole square. Now I see that this is also the a square minus b square identity. So I can write a plus b, that means b plus c plus a minus b, that is b minus c minus a. Now let's check the third expression. My third expression is c square minus a square minus 2ab minus b square. Here I see that a and b is with 2, so I'm going to group the variables a and b, equal to c square minus a square plus 2ab plus b square. From here I get c square minus this whole thing is equal to a plus b whole square, and now comparing to a square minus b square, I get c plus a plus b, and here I get c minus a minus b. And if we check carefully, that this is also equal to a plus b plus c, and this is also equal to a plus b plus c. Okay, so now let's use the Venn diagram to solve this. Here I have taken 3 circles in the Venn diagram, where the first one is my first expression. This circle, this denotes my first expression, and this circle denotes my second expression, and this one denotes the third expressions. Now let us see. What I find is, in my first expressions there are two factors, in the second also 2 factors, and in the third also 2 factors, and in three of them we have a same factor, that is a plus b plus c, And now if I check, in my first I have a plus b plus c and a minus b minus c. So a plus b here, and I have a minus b minus c here. In the second, if I check, then I get a plus b plus c and b minus c minus a. So the second one also has a plus b plus c, and another is b minus c minus a. And my third one has a plus b plus c and c minus a minus b. So it also has a plus b plus c, and it has c minus a minus b, c minus a minus b. only one factor is common in all of them and no factor is common among any of them. So I have denoted it here. Now let's check which is present in all of the three sets. So this thing is present in all of these three subsets. Therefore we can say from the Venn diagram, HCF is that factor which is present in all of these, that is A plus B plus C. A plus B plus C. This is our answer. Hence, you understood, I believe. If you find my video helpful, then share in your friend circle so that it would be proved helpful to all of them. And don't forget to subscribe my channel. Thank you for being with me.